The hunt for exoplanets has entered a new phase with the European Southern Observatory's spectrograph for rocky exoplanet and stable spectroscopic observations ESPRESSO achieving first light at the agency's Very Large Telescope VLT in Chile. The highly precise spectrograph will boost efforts to detect and analyze Earth-like planets and allow the VLT to fulfill its operational potential. The aggravating thing about science is that data gathering is only as precise and accurate as the least accurate part of the whole system. A simple example of this is measuring an object using a super-accurate set of calipers, then recording the result by making a drawing using a blunt pencil. It doesn't matter how good the calipers are. If that pencil isn't sharpened, all that precision will be wasted. The same is true for even the most sophisticated of instruments. The VLT is a world-class telescope, but the spectrographs attached to it can't exploit the capabilities of the VLT to its best. This is particularly important when it comes to hunting for extrasolar planets revolving about distant stars. Scientists are particularly keen to find small, rocky, Earth-like planets, but the transit method used by the Kepler Space Telescope, which looks at dips in a star's light intensity to detect planets, is limited and is biased toward finding giant Jupiter-like planets. Room where the light beams coming from the 4 VLT unit telescopes are brought together and fed into fibers, which in turn deliver the light to the spectrograph itself in another room. Credit Denis Mejavand, University of Geneva. An alternative technique for finding smaller planets is called the radial velocity method. This relies on the Doppler effect being detected by a sufficiently sensitive spectrograph. As a star rotates, one side will travel faster from our point of view because it's approaching us and the other will be slower because it's moving away. This causes the spectrum of the former to shift toward the blue end of the spectrum and the latter toward the red end. For a star without planets, this shift is very simple and symmetrical, but if a planet is orbiting it, it will cause the star to wobble and that will show up in the spectrum. By careful analysis, astronomers can determine if the unseen companion is a planet, how big it is, its composition, and the characteristics of its orbit. According to ACESO, the third-generation ESPRESSO is the instrument for the job. This is the first instrument that is able to use light collected by all four of the four telescopes that make up the VLT, giving it the resolution of a single, 16 meters (630 inches) telescope. ESPRESSO succeeds the HARPS instrument at the Lucilla Observatory, which has the ability to measure spectral velocities to within a meter per second. By contrast, ESPRESSO can measure velocities within centimeters per second. This not only allows ESPRESSO to hunt for rocky planets where life may exist, but also the minute observations needed to determine whether physical constants have changed over the billions of years since the Big Bang, and the composition of stars in other galaxies. The first tests of ESPRESSO were to look at stars in exoplanet systems that have already undergone extensive observation by HARPS. ESO says the tests were a success, demonstrating that ESPRESSO can obtain similar data with much less exposure time. This success is the result of the work of many people over 10 years. ESPRESSO isn't just the evolution of our previous instruments like HARPS, but it will be transformational, with its higher resolution and higher precision, says Francesco Pepe, lead ESPRESSO scientist. And unlike earlier instruments, it can exploit the VLT's collecting power. It can be used with all four of the VLT unit telescopes at the same time to simulate a 16-meter telescope. ESPRESSO will be unsurpassed for at least a decade. Now I am just impatient to find our first rocky planet. Video below provides a walk around the instrument. View Gallery 8 images.